Sayın Rektörüm, değerli mensuplarımız, sevgili öğrencilerimiz ve değerli ODTÜ ailesi. Learn and Connect 540 Lecture Series etkinliğimize hepiniz hoş geldiniz. Bu özel seri tüm ODTÜ'lüleri bir araya getirerek bilgi ve deneyim paylaşımını desteklemek, yeni işbirlikleri geliştirmek ve birlikte öğrenme kültürümüzü güçlendirmek amacıyla oluşturuldu. Bu seride sadece tek yönlü bir bilgi aktarımı değil, üniversite yönetimimiz, akademisyenlerimiz ve öğrencilerimiz olarak ODTÜ'nün geleceğini birlikte inşa etmek için güçlü bir iletişim platformu oluşturmayı amaçlıyoruz. Bu doğrultuda her birinizin katkısı, sorularınız ve görüşleriniz bu seriyi daha anlamlı hale getirecektir. Çünkü Learn and Connect, birlikte öğrenip, birlikte güçlendiğimiz bir platform olarak sizlerle hayat bulacak. Bu kapsamda her ayın ilk perşembesinde farklı bir akademisyenimizle 5.40 dersinde bir araya geleceğimizi duyurmaktan mutluluk duyuyoruz. Şimdi konuşmalarını yapmak üzere Rektörümüz Profesör Doktor Sayın Ahmet Yozgatlıgil'i kürsüye davet ediyorum.
ODTÜ ailesinin değerli üyeleri, hoş geldiniz öncelikli olarak etkinliğimize. Canlı yayından da Kıbrıs kampüsümüz izliyor. Onlara da selamlarımı, sevgilerimi sunuyorum. Bu ilk oturumda sizlerle bir arada olmaktan gerçekten çok büyük mutluluk duyuyoruz. Tabii açılış dersiyle başlamıştık aslında ilk defa üniversitemizin açılışında böyle bir önemli bir konuda, güncel bir konuda, üniversitemizin bir öğretim üyemizin araştırmasıyla ilgili bir konuda bilgi paylaşımı gerçekleştirelim. Böylece farklı disiplinlerin etkileşimi, yani üniversitemizde ne tür araştırmalar yapılıyoru birinci elden dinleme fırsatı yakaladık. Daha sonra da tabii bu bizim geleneksel, belki pandemiyle beraber ara verdiğimiz birlikte olalım etkinliğimiz. Yani o aslında açılış etkinliğinde gördük ki birbirimizle etkileşimimiz sadece bu öğretim üyeleri değil, aynı zamanda işte idari personelimiz, öğrencilerimizle beraber bir arada olacağımız, yani birlikte olacağımız bir platform da olsun istedik. Bu şekilde bir kurgu yaptık. Yani Learn and Connect 540 Lecture Series aslında bu tam ODTÜ'nün geleneklerini, kültürünü içeren 540 dersi. 540 aslında sınavlarla anılıyor ama 540'da belki olsa ek ders olur bu ama bu noktada işte derslerimizden çıktıktan sonra bir araya gelelim. Yine farklı bir alanda, yani bu etkinliğimizi her ayın ilk Perşembesi gerçekleştireceğiz. Kuzey Kıbrıs kampüsümüz de Cuma günleri bunu gerçekleştirecek. Cuma günü 5.40'da gerçekleştirecek. Biz onları izleyeceğiz, onlar da bizi izleyecekler. Kuzey Kıbrıs kampüsümüzün dersini de yarın 5.40'da biz YouTube üzerinden izleyeceğiz. Ama ben hepinizi temsilen oraya gideceğim ve orada olacağım. O kampüsün rektörü olarak 5.40 etkinliğinde Learn and Connect, aslında ona Cyprus dememiz lazım başına. Cyprus Learn and Connect 5.40 Lecture Series'te Kıbrıs kampüsümüzde, Güzelyurt kampüsümüzde beraber olacağız. Bu aslında dediğim gibi 5.40'da her ay farklı bir konu olacak. Yani ilk dersimizi aslında o dönemin açılış dersi gezegenler arası haberleşmeydi. Bugün burada Barış hocamızı dinleyeceğiz. Ana hatlarıyla iklim değişikliği. Bir sonraki ders gelecek ay henüz belli değil ama sizlerden gelen öneriler, talepler noktasında da şekillenecek. Belli bir listemiz ya da bir havuzumuz var. O havuz kapsamında sosyal bilimler alanında, uluslararası ilişkiler olur, farklı konular olur, mimarlık alanında. Burada işte kampüsümüzle ilgili belli bilgilendirmeler, planlamalar ve kampüsümüzün tarihiyle ya da işte araştırma konularıyla ilgili olur. Bunları değerlendiriyoruz. Yine eğitim fakültemizin yapay zeka ve eğitim noktasında güncel konularıyla ilgili olur. Temel bilimler, sonra mühendislik, böyle bir cycle'da aslında birçok farklı alanı her ay burada dinleyeceğiz. Tabii bugün biraz geç başladık, işte 5.40 dersinden çıkanlar, 5.30'da 4.40 dersinden çıkanlar, öğrencilerimiz burada, personelimiz burada, akademik personelimiz, idari personelimiz. Ama işte 5.40, 6.30 dersi, ondan sonra da işte fuaye alanında Connect kısmı, Learn kısmından sonra, Connect kısmında da bir kokteyl formatında, ayakta birbirimizle görüş alışverişinde, fikir alışverişinde farklı disiplinlerin bir araya geldiği, öğrencilerimizin öğretim üyelerimize tanıştığı, konuştuğu bir etkinliği aslında hayal ettik. Ve bugün burada olup bizlerle bu heyecanımızı paylaştığınız için çok mutluyuz. Aslında bu dediğim gibi inşallah geleneksel olarak ayın, yani yılın 12 ayını devam ettirmeyi hedefliyoruz. Ben tabii planda da kısaca her ay yine burada sizlere genel anlamda üniversitemizle ilgili konularda kısa bir hitapta planlıyorum bu etkinlik öncesi. Bu noktada sizlerle fikir alışverişini tabii dışarıda gerçekleştireceğiz ama gerçekleştirilen üniversitemizdeki yaptıklarımız ya da işte problemler ve diğer konularla ilgili sizlerle fikir paylaşımında bulunmayı hedefliyorum. Bu noktada göreve başladığımız süre yaklaşık 3 aya yaklaşıyor. Bu noktada aslında ilk etapta öğrencilerimiz üzerine odaklandık. Yemek, yurt, ulaşım ve spor gibi temel ihtiyaçlar, yaşam ihtiyaçlarıyla yakından ilgilendik. Elimizden gelen kaynaklarımızın optimizasyonu noktasında bazı iyileştirmeleri gerçekleştirdik. Tabii bu iyileştirmelere devam edeceğiz. Sürekli birlikte olacağız, sürekli bir arada olacağız ve sorunlarımıza, problemlerimize beraber çözümler bulacağız. Tabii bu konudaki yaklaşımlarımız ve bu konudaki iyileştirmelerimiz devam edecek. Yine tabii burada gördüğünüz araştırmaların devamı ve onların işte uluslararası alanda ODTÜ'den beklenilen dünyanın büyük problemlerine çözüm üretmek. Bu çözümü hep birlikte bütün paydaşlar üretmeyi hedefliyoruz. Bunlardan tabii ki bir tanesi bu iklim değişikliği konusu. ODTÜ'den beklenen bu alanlarda önemli çalışmaları toplumla paylaşması. Bu noktada araştırmamızla ilgili de öğretim üyelerimize, öğrencilerimize bu konudaki desteklerimizi en üst düzeyde gerçekleştireceğiz. Bu araştırma, eğitim ve topluma hizmet noktalarında beraberce ODTÜ standartını hayata geçireceğiz. Ben hepinize tekrar teşekkür ediyorum. Bugün zaten geciktik. Dışarıda devam ederiz. Ben çok fazla uzatmak istemiyorum. Ve sizleri dersimizle baş başa bırakıyorum. Sağ olun.
Sayın Rektörümüze teşekkür ediyoruz. Şimdi sizleri ODTÜ GİSAM'ın hazırlamış olduğu Learn and Connect teaser videosunu izlemeye davet ediyorum.
Welcome to Learn and Connect 540 Lecture Series. Every first Thursday of the month, we invite students, academics, and university staff to come together for an enlightening lecture presented by one of our esteemed researchers. After each captivating talk, step outside the hall to engage in vibrant networking sessions, connect with fellow learners, exchange ideas, and delve deeper into the topic of the day in a welcoming atmosphere. This month's lecture is Climate Change, Blue Economy, and the Role of Technology by Professor Barış Salihoğlu.
GİSAM'a hazırladıkları video için teşekkür ederiz. Sayın konuklarımız, ODTÜ'de bilirsiniz 8.40 dersleri meşhurdur. Ancak artık 5.40 dersleri de her ay tüm ODTÜ ailesini bir araya getirerek akademik olarak bilgilendirmenin yanında yeni bağlantılar kurmak ve bir arada olmak için gerçekleştirilecek. Bu kapsamda Lecture serimizin ilk dersi için çok heyecanlıyız. Şimdi serinin ilk dersini vermek üzere Deniz Bilimleri Enstitüsü Müdürü ve ODTÜ İKLİM Müdürü Profesör Doktor Sayın Barış Salihoğlu'nu kürsüye davet ediyorum.
Okay, dear all, I would like to welcome you all to our lecture series, and I'm really proud to be here presenting this first lecture of this series. And I would like to thank our rector, to Elif Hoca, and all the organizers for organizing this great event. I think it will be a very successful series of lectures. And I would like to start with very briefly introducing myself. I'm an oceanographer, actually a physical oceanographer, and I'm a graduate of METU. I have graduated from the Department of Petroleum Engineering. Then I did my master's at Institute of Marine Sciences. Afterwards, abroad, I did my PhD on physical oceanography, and for a little bit over 15 years, I have been in my home, METU, as the director of Marine Science Institute, and as well as the Climate Center at the moment. And our other campus in Turkey is at Erdemli, and this is the Marine Science Department, and this was established around 50 years ago. And in Erdemli, we also have the Kasım Center, the Marine Ecosystems and Climate Center, and also METU Climate Center has a room in that institute. The Marine Science Institute focuses on a various of topics, of course, mainly on marine sciences, starting from physical oceanography to biological oceanography, but also understanding the effect of different stressors, for example, climate change on the oceans, and we focus on the deep seas, the polar seas, and the atmosphere as well. And more, we are focusing on the socio-ecological aspects of marine sciences. Okay, today's lecture will be around 45 minutes, then we will have a brief time for a few critical questions. And the outline is, as you have seen in the title, will include the challenges. Is the planet's life support system, the biosphere, is it failing? So what's happening? What are the most updated status of climate change and how it's affecting us? And then we will focus on solutions and opportunities. And this will be on the main axis will be technology, how we can benefit from the technology to combat climate change. Okay, the challenges are there, but these challenges are very complicated. And very recent research has shown that we started seeing some unexpected effects of climate change. And one of them, which is an alarming one, for example, last year, trees and land absorb almost no carbon dioxide. Why is this alarming? Because as you may know, trees, land, together with oceans, it absorbs almost half of all the human carbon emissions every year. And last year, this did not happen by trees, forests, and land. So this is worrisome. And something similar is also happening at the seas. How seas are absorbing carbon dioxide is also unstable. And seas and oceans are the main mechanism that absorb carbon dioxide from the atmosphere. How does this happen? The tiny microscopic plants at the surface of the sea that does photosynthesis during the daytime are being grazed by billions of little creatures that migrate to the ocean surface every night. This is the biggest migration that's happening on planet Earth every day. They migrate to the surface, feed on these microscopic plants, they migrate back, and their waste transfers carbon to the deep ocean. This is the biggest carbon export, carbon sink mechanism, and this is also not stable today. But why is this happening? There are several reasons. One of them is the one that you know the best, is warming because of increased carbon dioxide in the atmosphere. But it's official now that 2023 was the warmest year on record, and during the last 47 years, there was not a single year that was cooler than the average Earth temperature. And a very recent finding has shown us that this year that we are in, 2024, will be again the warmest. It will be a record year. But what's worse is that, as you know, when we talk about climate change, we always talk about, okay, will we be able to stop at 1.5 degrees increase? Most probably, this year we will see that we will be at 1.5 degrees increase already. So we are already beyond this main threshold of 1.5. So what's happening at the oceans that absorb most of the heat is that oceans are also warming up. And what you see here is that the anomaly from average temperatures, how oceans and seas are warming up. Please focus on the region where Turkey is. You see the Black Sea, the Mediterranean are the seas that are heating up the most with increasing carbon dioxide levels in the atmosphere. And around Turkey, in the seas and in the atmosphere, we see the record warmest temperature or much warmer than average temperatures. So we are in a very delicate area, and our ecosystems are quite fragile because of that. And it's not that only the temperatures are increasing, but the rate how these temperatures are increasing is also increasing. So compared to the last 100 years, if we look at the last 30 years, the increase rate of temperatures is much higher. And all these is very hard to be accounted. For example, what I have shown you, this collapse of carbon dioxide sink was not accounted by climate models. It's new, and still we are trying to understand why it's happening. What are the other effects? It's not only temperature increase, right? Also, the precipitation rate is changing. In our region, if you look at the Mediterranean region, with 1.5 degrees going to 4 degrees increase, these are the model forecasts, we will most probably experience over the next few decades at least 20 to 30% of precipitation decrease in our region. Our region is becoming drier other than some small parts of the Black Sea. Another effect is soil moisture. It's not only decrease in precipitation, but soil moisture also affects the land. And soil moisture is increasing with climate change. And one of the main effects of decreased soil moisture is that we are losing different types of trees. The vegetation is changing, but also forest fires are increasing because of this. Why do we see all these forest fires that are increasing? Because the soil moisture is changing. And another not very well known effect of climate change is extreme events. We have seen very recently in Spain, more than 200 people unfortunately died because of floods. These floods in Spain also changed the coastline in Spain. And the heavy precipitation events that would occur normally every 10 years, nowadays is occurring 1.3 times more frequently, and in the future, most probably this will occur even 3 times more than what we have been observing. And small changes in climate really affects the extreme events. The extreme event frequency increases. For example, extreme temperature events that we see every 50 years if the temperatures go up to 4 degrees, may increase almost 40 times. So these heat waves we will start seeing even more and more frequently, which will be followed by fires and dry land. Other effects are on health, like for example, here what you see, this is an IPCC result, that the number of days that will be not favorable for human health will increase dramatically in most parts of the earth. So there will be direct consequences for human health as well as food production. So for health and for food security, there are many challenges ahead of us that we need to start accounting for today. And this needs to stop. Otherwise, this is jeopardizing the human welfare and the ecosystems. Okay, what I have shown until now, I believe is quite overwhelming, and I couldn't show you any good news. So most probably, we all need to take a deep breath, or maybe two. So a small breathing exercise. I will ask you to all take a deep breath now. Please, let's all together inhale and then exhale. Let's take another deep breath. Inhale and exhale. Now, I would like to tell you that one of these two breaths that you took came from the ocean. The oxygen that we breathe in the atmosphere, even here in Ankara, far from the sea, most of it comes from the sea. These little microscopic plants, they produce the oxygen in the sea, and they are responsible of most of the oxygen that we breathe. So every second breath that we take comes from the ocean, and oceans not only they provide oxygen, but they absorb most of the carbon dioxide as well, and they regulate the climate. The ocean heat content is storing almost 90% of the excess heat that anthropogenically we are producing. And the oceans store 50 times more carbon dioxide than the atmosphere. And we benefit from many services that the oceans provide. For example, medicine, food, and other services that I will be talking about. However, the oceans are not very well discovered. One of the critical aspects how oceans regulate climate is the excess energy accumulation in the oceans. The heat content as they accumulate is increasing. So, okay, we are heating up the Earth, the planet, and the oceans are absorbing most of it. Like 90% of the excess heat is absorbed by the oceans, but this comes with a cost that we have seen. The temperature increase, the changes in circulation fields, and ocean acidification. How does it happen? What you see here is that the increase in atmospheric carbon dioxide. When the carbon dioxide increases in the atmosphere, in parallel, it increases, the PCO2 increases in the ocean as well. However, this decreases the pH of the oceans. And some of the scientists, they address this as more critical than the increase in temperatures. And this is called ocean acidification, and it is the climate change's evil twin. So what happens when the carbon dioxide levels in the atmosphere increases? Then there's more carbon dioxide being soluble in seawater, uptaken by plants, and then the carbonic acid, free hydrogen ions, and bicarbonate levels increase. But how does this affect the decreased pH levels? They directly affect the life in the oceans. So corals, mollusks, and other marine calcifiers, they cannot grow. They have already started shrinking. And most probably you have heard about bleaching of the corals. This is causing the bleaching of corals as well. And if ocean acidification continues in this rate, most probably in 15, 20 years, we will not have any warm sea corals. So this is a main threat as well that we need to tackle, and the oceans expected to be 150% more acidic than they are today. Also, sea levels are increasing. So we are in the Mediterranean region, but this doesn't mean that because Mediterranean region is a semi-closed sea basin, the sea levels will not increase. These sea levels will increase, and 1 centimeter of increase in the sea level means a loss of 1 meter of a beach, of land. So the predictions show that changing between the best case scenario and the worst case scenario of climate, in the Mediterranean region, 30 to 70 centimeters of sea level increase will occur. And this is some analysis that we have done around our country. This shows the average temperature rise. And in our seas, the temperature rise is way beyond the global average. The average is around 1.5, but this highly changes between regions. When you look at the eastern part of the Black Sea or the eastern Mediterranean, you see that the temperatures already increased almost by 2 degrees. And when we look at all year around in different seas around Turkey, what we have seen that the black line here is the average temperatures. The last 2 years are indicated here with dark purple and red. What we see is that very warm winters. People generally realize that summers are very hot, but actually the winters were very hot, and we have experienced record high temperatures during the winters. Similar at the peaks of the summers. Nowadays, we are back to average values, but in overall, the decrease around our seas compared to the average is above 2 degrees. And climate change is not the only stressor on the oceans. There are other stressors. For example, pollution. We are polluting the seas. And there are sea land-based sectoral activities that put pressure on the seas. Deoxygenation, acidification we have talked about, and with fish. And generally, in almost all Earth seas, the fish is being overfished, and with changing temperatures, invasive species are also increasing in these seas. So we have talked about climate regulation, the critical role the oceans play. They're the blue carbon, but oceans are home to a very diverse life, the biodiversity, and we are also losing that. And there's a lot of potential for ocean energy. Just 0.5% of energy in ocean waste could meet the world's energy needs 5 times over. So there's a vast amount of energy that can be tapped. And the economic value of oceans is quite large. Ocean economy is the 7th largest economy in the world. And as I have mentioned, we benefit from the oceans in terms of different services. So, are there solutions? Are there opportunities? How can we have a healthy and a sustainable blue economy contributing to climate change? So, oceans support many sectors, but this comes through services. All ecosystems provide services, and these services are under 4 categories. For example, provisioning. This is food, for example. Food is a service, or transportation or recreation. Cultural services, like natural heritage, and regulating services. We have talked about this, regulation on climate. This may not have a direct market value, but it's very, very valuable, as you can imagine. Or supporting services like primary production, and the oxygen comes from the oceans. So we need to understand how these services are being affected with our behavior. So without understanding that, it's not possible to have a healthy economy with a healthy ecosystem. I will talk about these boundaries of the planet, but first, what's blue economy? First of all, there wouldn't be any green growth or green economy without blue. So the blue economy it addresses inclusiveness and it improves the lives of all. But how? Through sustainable ecosystems. So the fisheries needs to be ecosystem-based. How we benefit from the ocean needs to be ecosystem-based, and the energy. It requires using renewable energy, and the pollution should be dropped. And at the end, the blue economy creates jobs, reduces poverty and hunger. So these services that we talk about, they support different sectors. And under the blue economy, there are two different of sectors that we see. The well-established sectors, for example, tourism or fisheries, but there are also barriers in front of them. Tourism is not sustainable at the moment, but it can be easily converted to a sustainable practice. It's harder with fisheries. And on the other hand, there are emerging sectors like biotech, offshore wind platforms. This is one of the sectors that's expected to grow most among all the economies, and desalination, which is also growing very fast. These are just some examples. So on one hand, we need to remove the barriers in front of the established sectors, and on the other hand, we need to start adapting these emerging sectors. Of course, if we are saying green or blue, this needs to be sustainable and preferably zero carbon. And the growth rate of blue economy just before the pandemic was expected to double by 2030. Of course, some sectors would grow faster, but all of them are expected to grow. So I asked ChatGPT how blue economy can be important for Turkey's national technology development. And this is what the answer I got, and I fully agree, so I put it here. The blue technologies support development of national technologies, economic growth and employment, sustainability, defense industry, and security. So as METU, together with our partners, how can we support this? I want to talk about this a little bit. So I would like to take this opportunity to talk about the METU Climate Center that I'm the director of. This is an umbrella center. As you know, in METU there are many different disciplines that carry out research on climate change. This can be directly on understanding how climate change is occurring or how it's affecting the ecosystems, or it can be on technology developments towards addressing climate change, establishing smart zero carbon cities, on circular economy, education, clean energy, and policy from our social departments. So this list is not exhaustive, but we made the first workshop of this climate center, and over 70 faculty members were interested from many different disciplines. So the idea here is to bring together these disciplines and bring up front this very strong aspect of METU under one umbrella. So METU Climate Center has its headquarters in research and park offices. It also has space in Erdemli campus in the climate center there. And when we look at SDG 13, the climate action, it's overarching with almost all SDGs. So it's really encompassing. And because METU has this diverse background in disciplines that are addressing on the different themes of climate change, I think it's one of the strongest institutions in Turkey and also internationally that can focus on many different aspects of climate change, but together this gives us a better strength. And this center is already part of 4 BINDOT projects, which are technology platform projects, and we are leading one. We have submitted this, which I will talk about, and many other projects are either funded or on the way. And DECOSIM, the Center on Marine Ecosystems and Climate, is in Erdemli, and it supports technology development to continuous observation of climate change, and also producing digital twins of the oceans. It has many modules, observational modules, to decision support tools and forecasting tools like digital twins that I will address. Okay. To adapt and to mitigate climate change, one of the emerging concepts is multi-use ocean platforms. And these ocean platforms can help sink further carbon dioxide to the oceans, can uptake. They can be not only carbon zero, they can be even carbon negative by, for example, supporting algae production for the industry. So ocean-based mitigation has a huge potential, and with these platforms, they optimize the area use of the oceans, and they support technology development both on land and the oceans, and they can close a huge gap in the emissions up to 20%. And under the umbrella of ODTÜ İKLİM, we have put together a project called MaviTech, and MaviTech enables development of different technological fields, primarily including offshore wind, solar energy, green hydrogen, extraction of critical raw materials, biotechnology, carbon sequestration, and also innovative observations and digital twins. And the consortium here is a true collaborative consortium between the academia and the industry, as well as different public institutions, together with, of course, collaboration with the international partners. So, how can we benefit from technology towards addressing the challenges of climate change? These platforms, these offshore platforms, as I say, they optimize the ocean use, and under the first pillar, we are aiming to develop these platforms, to design them for all the seas of Turkey, together with legislation and strategies. And under the second pillar, the development of renewable energy technologies and the prototype. So a prototype, a real prototype, which will be the first prototype in Turkey. And in terms of different technological fields, this will be a first in Europe as well. It will use solar power. The wind, we will test it separately in Rüzgem, but it will directly include green hydrogen from the seawater, which is cutting-edge technology. Already unmanned vehicles with some defense companies that will be charged with this renewable energy, and algae, so proteins from algae. For example, algae cultivation will be part of this. Under the third pillar, this is extraction of raw materials like hydrogen, as I have mentioned. Its technology will be developed here, but other materials, for example, lithium. If we are talking about green transition, elements like lithium will be very critical, and already we are exhausting them on land. So there are already some approaches to start cultivating them from the sea. Under the fourth pillar, this is blue biotech. So this benefits from living organisms for food, for medicine, for sanitation, and even for defense industry like nanocellulose, very high endurance materials from different living forms. And all these technologies will be carbon zero and sustainable, and they will be merged under this platform. And under Pillar 5, this is an observation data and digital supporting systems, which includes the digital twin of the oceans, but also it includes unmanned vehicles and unmanned flying objects. And we'll be doing this again with leading industrial partners. Okay, so digital twins. Now I'd like to talk about the digital twins, which is a technology that's most needed to manage this whole ecosystem. And digital twins are being already widely used in different disciplines. So a digital twin is a virtual representation of an object or a system. And for example, there can be a digital twin of an airplane or buildings and cities. However, when it comes to, for example, bodily organs or planet Earth, it's more challenging because the amount of data that's required for this digital twin is limited. But we need to start somewhere, and we are already talking about planet Earth digital twin. And a digital twin needs to have real-time data flow. So as from a, for example, power generator, this can be easier. The sensors are there. You can already adapt them and have the data flow. So continuous learning, it uses AI and machine learning. So you don't only rely on models, and this increases the accuracy over time, and it's applied across many industries. And now I would like to give you an example from one of our seas, the most critical sea, the inland sea, Marmara, how we are developing a digital twin and what are the challenges we are facing there, and how I'm hoping that this will be interesting for you. I'm just checking my time. Okay, I'm going on time. I have another 15 minutes or so. I will give some examples from Marmara Sea and then the Black Sea. The Marmara Sea is one of the seas that's under almost all the stressors that we humans are inducing. These stressors are pollution, climate events, acidification. Recently we had the mucilage, sea snot. I'm sure most of you heard chemical pollution, invasive species, marine litter, plastics. So how can you manage a sea as such, and how can you provide the decision makers or the policy makers the tools that they need to manage a sea like that so we don't see an event like mucilage again? This is a nighttime satellite image of Marmara region. Around Marmara region, like almost 50%, half of the industry of Turkey is around the Marmara region, around this small inland sea, which is already highly fragile. And because of this, at the end of 2021, we have seen the mucilage event. And Marmara Sea is a very distinct sea because at the top level, it's the Black Sea water. The lighter, less saline Black Sea water flows on top, and underneath it's the Mediterranean sea water. It's very unique. There's no sea as such in the world. So what happened with all the pollution and all the industry around Marmara Sea? These are oxygen profiles, what you see here. So you see the decrease in oxygen levels in the Marmara Sea. So it became almost deoxygenated. And as I have shown you, Marmara Sea is unique because the deeper waters are formed by the surface Mediterranean water. And it's one of the seas that deeper waters are heating up as well because of this. Because surface waters in the ocean heat up more in the oceans, but in the Marmara Sea, the deeper waters are heating up as well. These are oxygen transects over time, starting from 1980s to today. This is a transect starting from the Straits of Dardanelles, going to Izmit Way. So you see how oxygen levels decreased over time. But why did this increase? The main result is the amount of organic material that goes into seas. Okay, when there's more production, when this tiny phytoplankton produces its high production, it can sound like a positive thing, but if it's too much, so what happens if there is too much living creatures at the surface of the sea? They die at the end. When they die, they start sinking. When they sink, they decompose and they consume oxygen. So it shouldn't be too much. So when it's too much, this starts creating low oxygen zones like happening in the Marmara Sea. And in July 2021, our Bilim ship was there 11 times. We had to send our ship there 11 times because decision makers needed to understand what's happening. Thanks to our data for 40 years, we have shown them what was happening. And we have actually shown what the solutions can be. So here you see at the surface, this is turbidity, there's mucilage, and this is without mucilage, after mucilage ends. After mucilage ends, the productivity continued, the high productivity, but this didn't help the low oxygen levels below the surface. So we have started with our ministry, a modeling system which now is being converted to a digital twin of Marmara Sea. The main aim was to understand the Marmara Sea's ecosystem today and how we can manage the sectors in Marmara Sea, but so that the Marmara Sea goes back to its healthy state. Maybe it will never go to its pristine state, but to a healthier and a more oxygenated Marmara Sea, how we can achieve this. So first, we have developed the 3D digital tools, which was not easy. We have started with the 1D modeling tool because decision makers needed immediate solutions. So we have developed the model of the ecosystem, and we have tested many different scenarios for our decision makers. And one of the most suitable scenario was that we reduce the land pollution by 35%, and we reduce what we are injecting into Bosphorus from the cities by 75%. If we did this, we ran these models in at that time, this was before mucilage in 2017, and we have shown that our oxygen levels would go up the desired oxygen levels, which is 80 micromoles per meter cube in several years. But when we look at the Marmara, we are still here because business as usual scenario has continued. And now we are developing the 3D version of this, which will be integrated into the digital twin. A digital twin is not only being fed by data, and it's not only composed of models, but it also needs to have early warning systems supported by artificial intelligence tools, and it needs to produce management tools, and it needs to include socioeconomic data as well. So, first, we have developed the 3D version, the physical model of the Marmara Sea. This is the physical model that's running the circulation fields, the temperature fields, the salinity fields in the Marmara Sea. This was a big challenge because, as I have shown you, Marmara is a very complicated sea. So on top of this, the ecosystem model came, and we have very quickly at that time tested some scenarios. What would happen if we continue with current pollution levels? What you see here is that oxygen levels at 35 meters. So what you see with blue is low oxygen levels. And what happens if we reduce the pollution by 50%? And this is the difference. So because Marmara Sea is fed by high oxygenated Mediterranean water, it's possible that in several years we have started some considerable oxygen increase in the Marmara Sea. Of course, all these modeling efforts needs to be supported by high technology observations. For example, the glider, which was given to our university by İşbank, you see the high frequency observations. These are unmanned vehicles. Maybe we should also start thinking about developing these vehicles. So what did at the end we tell to decision and policymakers? What you see here in red is discharges from the cities. And what you see in blue is what comes from rivers. This is the pollution, mainly nitrogen and phosphate. So we have shown them which wastewater treatment plants are polluting the most and where they should increase the capacity of these wastewater plants. And what we have shown is that because of industry and also because of agriculture, a lot of pollution is coming from the Susurluk part of Marmara Sea. And we need to develop natural wetlands around them, and we need to go towards better practices of agriculture. So all these plans are presented to the decision makers, and at the end, this formed the core of the Marmara Denizi Koruma Eylem Planı. Without all these critical findings, we wouldn't be able to develop this plan. So this was a very good example how science directly contributed to policy making and decision making. Okay, we have led 2 EU projects coordinated in the Black Sea. Now I would like to move to the Black Sea, and one of them is the Bridge Black Sea project, which is a huge €9 million project, which I'm the coordinator of. And within this project, we are trying to understand how we can develop a safe operating space for our ecosystems that can support a strong blue economy. So to understand this, one of the first concepts is to understand what's a safe operating space. So to combat climate change, researchers developed the understanding of safe operating space and the boundaries. For example, the boundaries of biodiversity or ocean acidification. So we need to stay within the safe boundaries and support the green economies. But it's not so easy to understand in terms of ecological aspects where we are, if we are within these boundaries or not. One of the positive, maybe, motivating aspects is that in terms of ozone depletion, as you know, ozone was one of the main problems in the past, but now we are within the safe limits. So we have realized the critical aspects of it, so we have pulled it back. So this is promising. Maybe we can also stay within the boundaries of the planet while supporting our economies. So to achieve this, to understand the safe operating space in the Black Sea, Bridge develops knowledge-based modeling approaches, resilience analysis, and adaptive management tools like supported by cumulative effect assessment and machine learning. So to do this, I know this is crowded, but I will try my best. For example, we developed different imaginaries for the Black Sea. So this is exactly how you test what-if scenarios with your digital twins. So on one side, there was technology development, on the other side, social innovation. So this was based on the European Environmental Agency scenarios that we have adapted to the Black Sea. They all were sustainable socioeconomic scenarios, so we have tested. So different IPCC SSPs scenarios were tested by our models, and the resilience assessment was done for the first time in the Black Sea, supported by adaptive management tools here. So these are different socioeconomic scenarios I was telling you, some more focused on developing technologies, some more on social aspects, and we have tested all these tools in a what-if manner with our digital twin. However, you need to combine them with different climate scenarios, different SSPs, best case, worst case scenarios, and these results are very new. Actually, I'm showing them for the first time. So we did forecasts in the Black Sea until the end of the century to see how sea surface temperatures will increase till the end of the century by when we test the best case and the worst case. In the worst case, we have seen that 30% increase in temperatures, which is very high, and the primary production levels will decrease by 20%, as well as the oxygen levels show a high decrease. So with the best case scenarios, still some negativity continues, but of course it's much more promising. So if we decrease the carbon dioxide levels in the atmosphere, if we limit our emissions, there is a lot of hope. And when you are talking about a digital twin, you need to have some visuals that your end users can benefit. So seas are 3D. So it's much more complicated than land within this respect. So you need to understand the depths of the seas, and there are some strong tools that can be used. And we have tested different scenarios at different pilot sites as well, at different countries. And in these countries, some socioeconomic analysis has told us or indicating from smart observations which we are developing. Of course, these needs to be further supported by technologies, and continuous data flow is needed for this digital twin. And we have organized 2 high technology summits of the Black Sea, which was very successful. When we have started this project, when we talked about blue economy, the reactions we got was like, no one understands about sustainable blue economy. There are not even any startups. In our last high-tech summit, we have supported 50 startups. 50 startups applied, and we have supported 15 of them. So this has shown the support, the power of actually science, how it shows the way to the industry as well. And these are tools how different stakeholders can visualize and benefit from these digital twins. And in Europe, there are different, at the moment, initiatives on digital twins, and Bridge is part of the digital twin ocean of Europe already as a demonstrator. So we have established one of the first demonstrators. And lastly, okay, technology innovation is extremely critical if we are talking about climate change, zero carbon, but regional cooperation is also very critical. So keeping this in mind, we have developed different strategies for different regions in the Black Sea. We have led this effort with our Connect project. Actually, this project is one of the projects that we have recently been awarded. And the main idea of this project was to develop national agendas through science diplomacy. So all these different technological aspects that I have been telling you about, or the research aspects, were in a strategic manner planned here in the strategic research and innovation agenda. And then an implementation plan was developed that would directly include actionable recommendations. And this implementation plan was launched in the European Parliament. So it had a high impact directly at the level of decision makers. And also, the ministries of all the countries formed a common maritime agenda, and Turkey had led last year the common maritime agenda, and our minister has hosted this, where I had the honor of moderating this ministers' common maritime agenda meeting. And they have endorsed this implementation plan. So the priorities in this implementation plan, which are listed here, are already endorsed by countries, and they are being uptaken in the agendas of the countries. So this shows how you go from science, research, to directly at the level of policy making. And what this implementation plan includes, for example, new technologies towards aquaculture and marine culture, blue biotech, healthy coasts for the Black Sea, combating marine litter, and marine renewable energy are some of them. And of course, it includes the socio-economical aspects as well. And the impact of this project was so high that both the European Commission and YÖK and our president has awarded it with a prize. So METU is not only in Marmara or the Black Sea. The trans-basin efforts are also going on. For example, as METU, we are a hub in the Mediterranean as well, where we are developing the new research fields, ideas, which are being integrated into the Horizon programs as well for new calls. And carbon sequestration by the seas is becoming one of the new strong tools where even countries utilize this to discuss about climate change, or they include them in their negotiations, because on land, the carbon uptake is being considered in climate negotiations, but what's happening at the coast is also being integrated into policy. And here we are using with Chinese institutes. We are working with Chinese institutes. So challenges are common. even in Europe and between China, we have similar challenges, so we are benefiting from each other's experience to develop solutions. So from European basins to across the world, you need to include scientific communications. So at the end of my talk, I would like to tell you that there's hope. There's great hope, yes. How it looks now, it's a bit dim, but if we utilize technologies, if we utilize innovation, together with the stakeholders, all the stakeholders together, we can develop solutions for a climate-resilient ecosystem and a climate-resilient economy. But what we need to do together is that we need to combine our different disciplines. So starting from basic sciences to technologies to social disciplines, if all come together, we can develop solutions which can be used by decision makers. It's possible to transfer this knowledge to decision makers, which I have shown you now. So with this, I would like to end my talk, and I would like to thank you for your patience and for being here. I think we can take a few critical questions if there are any. Otherwise, we can continue at the cocktail. Any questions? I think there's one.
Thank you, Barış Hocam, for this informative and encompassing talk, combining engineering and social sciences and maybe everything related to what we have on this earth. So one question I have is about the graph, summer-winter graph. We have almost bi-weekly heat waves, like every second week, which we all talk about in our daily lives over the summer. Like 2 weeks ago was so hot. This week is again so hot, but there's small average hot times in these summers. Remembering unstable systems tend to blow up with oscillations. So do we know why, or do you analyze why this happens? And the second question would be, I've heard ocean energy harvesting devices are now being developed over Europe. So instead of wind turning turbines, down in the ocean, there would be work harvested from the ocean to feed electrical lines. Would that help reduce the average temperature of the ocean? So 2 questions, bi-weekly.
Okay, thank
Thanks.
you. Yeah. The temperature changes at the local scale. It's not only dependent on the global trends. Yes, there's the global seasonal cycle of the Earth affected by the sun. But beyond that, at the local scale, the temperatures or the weather is affected by both, regional climate indexes, for example, ENSO, we had the El Nino, but also local events. So the local heat exchange between the basins affect these fluctuations. So most of these fluctuations are local, but the general trends, seasonal trends, are more global. And about energy from the oceans, yes, we need to understand how they are going to affect the ocean ecosystems and even the ocean physics. So it's not that maybe heating will not be our main concern, but how this is being affected by the ecosystem around it and how these systems will affect the ecosystem is our main concern, and definitely we need to develop sustainable methods for this. But it shouldn't disturb the general circulation characteristics of the oceans. Then it will affect the temperatures as well, of course.
So do you mean locally the 2 weeks are different in different regions?
Yes, it's different. It's
So
not. It's not.
sampled from a specific.
Yeah, yeah. It's not
location.
2 weekly.
Not necessarily.
It's not. Yeah, 2 weekly events.
What?
Yeah, there's no such.
Peaks are not same all over the.
No, it's not. Yes, I mean,
Thank
when we are experiencing colder, warmer winters, it's possible that Europe is experiencing colder. Yes, the Earth is not also changing at the global level at the same. Some parts are cooling because of melting ice, for example, while the other parts are warming up. Yeah.
Professor, thank you for this enlightening lecture. Diplomacy, you made a point. What the countries plan for this? Because this is a MENA region, Middle East and North Africa. This is a chaotic region. Not only the countries, but also the governments should agree on what to do together. Do you have any projections, or these projects have any projection about this? Thank you.
Yeah, thank you. Very good point. When we have started in the Black Sea as the representatives of our countries, it was not possible to bring together the 6 different Black Sea countries around one table. But science really helped. So as scientists, researchers from all these countries, we sat together, we defined the priorities of different countries, we defined global common priorities, and then we met at the minimum grounds. And after meeting at these minimum grounds, we have presented them to the decision makers and the politicians. So it was going quite well in the Black Sea, to be honest. All countries undersigned, for example, the Black Sea Strategic Research and Innovation Agenda that we are prepared until the war. So now Russia is out, Ukraine is not functioning very well, so suddenly we lost 2 countries in this collaboration. So that's upsetting, and that slows us down in the Black Sea, but as rest of the countries, we are still trying to move forward, but there's a gap. In the Mediterranean, it's more complicated. There are more conflicts, but again, we are trying to meet at at least at some minimum grounds. But when it comes to signing these agreements by countries, because there are conflicts in terms of exclusive economic zones in the Mediterranean, is not that easy. And again, we are experiencing wars in the Mediterranean. So it's very challenging, especially in the Black Sea and in the Mediterranean region. But it's moving. Slow, but it's moving forward, yes. And I think it's getting late, and we can continue these discussions during the cocktail hour outside. I believe we will continue for a while. Rektör hocam, dışarıda devam ediyoruz. Öyle değil mi? Evet. Dışarıda devam edeceğiz. Çok teşekkür ediyorum. Teşekkürler. Sağ olun. Sağ olun.